So this section is 12.2, recognizing graphs of exponential functions. And what's really interesting is on this one table here, where it shows what happens to the curves as you change the a in the equation, the growth factor or the decay factor. When you change them, this is what happens. So let's do that on the calculator. Let's go to the y equals button and clear out any equations that's there, and I'm going to type in 2.5 to the power of x. Okay, and then I'm also going to do the 1.7 to the power of x, and then I'm going to go to 1.3 to the power of x. Okay, and now I'll just do zoom 6. And you can see here's what it looks like when it's 2.5. Okay, and then here what happens when we make it smaller, 1.7. It doesn't grow as fast. And then this is the 1.3, which doesn't grow nearly as fast either. So as A gets larger, meaning as it gets bigger than 1, because that's what it did here, 1.7, 2.5. As it gets bigger than 1, the exponential growth increases quicker. Okay, so now let's take a look at the decay. So I'll clear these out and go to the decay. So they said, let's say it's 0.15 to the power of x, and then we have 0.5 to the power of x. Oops, I don't want to do that. I keep doing that. And we do 0.7 to the power of x. Okay, and we hit graph. So the first one is 0.15, so it's further away from 1. Now it's getting closer to 1 and even closer to 1. So as the fraction becomes closer and closer to 1, it doesn't grow as steep. We're actually getting more of a straight line. But the smaller the fraction, the steeper it is. So it's decaying much quicker when you make the fractions smaller. So this is a good pattern to see in this particular growth and decay exponential functions. So that's what's nice to see. Now, if we want to transform exponential equations, meaning move them to the left or move them to the right, they behave just like we've done with other equations, just that we just add that to the exponent. So that's what they're doing here, is we have an original equation at 2 to the x, but then if we want to move it to the right, we would actually just say x plus 2. So let's take a look at that. We'll clear it. Okay. And so let's put in the normal equation. Let's just say it's 2 to the power of x. Okay. And then if we want to move the equation to the right, we would go 2 to the power of x plus 1. Okay. And so now when I hit graph, you see what it looks like originally as a growth, and then how you can actually move the equation 2 units to the left. And so that's what's happening. It moves it to the left. And that's kind of unusual because most people think, oh, this actually moves to the right. And maybe I said that originally, but really it's not. It's going the other way. It's going to the left instead of the right. So that's something to see again. That here, the first equation is here. Okay, and then it moved it to the left because you added 1 unit to it. Let's go back and do another one. Let's say we want to do 2 to the power of x minus 5. You can kind of really see it. So this means it's going to actually move the equation to the right. So let's do that. let's go ahead and graph and see what it does. Yep, that's exactly what it did. It took the original equation and shifted it 5 units to the right. So when we are doing this, we want to make sure that we're aware that when we say x to the power of x plus 1, it actually moves the equation to the left. And if we say x minus 5, it moves it to the right. So that's kind of unusual. We didn't expect that to begin with. Okay, so let's take a look at the next page. Comparing linear equations to exponential, it's obvious from the curve that the exponential ones grow, if we go far enough into the bigger x values, the exponential grows much quicker than linear equations do. And this is nice because this is how our money grows. We want it to grow exponentially where we don't want it to grow linearly. So that's a nice thing to point out. And you can see the same thing when we look at exponential versus polynomials like x squared only. We see that exponentials grow way quicker than a regular polynomial expression would do. And so that's nice to see just how fast it grows. It grows really quick. And so that's a nice example table to look at. And then they go through finding linear and exponential functions, which we'll do in the next video tape.